Alright, boys and girls, welcome to the drive-through for our first order of the year here in Algebra 2. Hungry? Stop by the deli. Make yourself a sandwich. Okay, so this is section 1.4 and 1.5. We're going to go pretty quick here to start the year because this is review, but we're reviewing because this stuff's important. So the first thing we're going to do is we're going to solve an equation. The things to remember on this would be show every step. That's the easiest way to figure out where you are making mistakes, which is the best way to learn in life, okay? And then the second thing I would tell you to do is do the inverse operation. Okay, so for this one, you got all of the x's are on the left side of our equal sign, so there's nothing to do at the beginning other than clean this thing up. So we're going to distribute, okay, and that'll give us 10x minus a negative 3 times 2 is a negative 6, a negative 3 times 2x is a negative 6x, plus 20, I draw that line so I keep my equals on it, equals a negative 10, okay? Combine like terms, these are like terms, that gives you 4x, a negative 6 and a positive 20 give you a positive 14. Leave my equal sign right where it is, okay? Now I want to get all the x's by themselves, so what's being done? We're going to subtract 14, and so you get 4x equals negative 24, and now the last thing being done is multiplication, so the opposite of multiplication is divide. 4 divided by 4 is 1. 1 times x, so that's legal. X equals negative 6, okay? Let's check my answer to see if that's right. You got a negative 60 minus 3 times, let's see, negative 12 plus 2 is a negative 10. Plus 20, and does that equal negative 10? Oh, negative 60 minus 30 is negative 90. Negative 90. Oh, no. Negative 60 plus 30 plus 20 equals negative 10. Yes, it does. Okay? All right. Just wanted to remind you could check your answers there. Okay, example 2. Okay, things to remember. Okay, well, the biggest thing with this one is don't get intimidated. Okay? I know this looks significantly more complex, but in this equation, this is all we're treating as a variable. We just want to get that by itself, okay? Well, we need to get rid of the L, and we need to get rid of the subtraction here of the adding of the 1, okay? So, if you divide each side by L, then we're going to have 1 minus r on the right. That's pretty simple, so that's what I'm going to do. I'm going to divide each side by L. So what I have is S over L equals, and then I'll leave it in parentheses so I don't confuse you guys, 1 minus r. So that's the same thing as S over L equals negative r plus 1. You remember that you can add things in any order that you want? Okay, 3 plus 4 is the same thing as 4 plus 3. So all I've done there is taken away the parentheses and switched the order that those things were being added, if that makes sense. All right, so now maybe that's easier for you to see that I'm going to subtract 1. So you get S divided by L minus 1 equals a negative R. Now I got to divide each side by negative 1. And that leaves you with, okay, S over L divided by negative 1 is just a negative S over L, and a negative 1 divided by negative 1 is a positive 1. Not easy, okay? That's why we're making these videos to help. Okay, the product of a number and 4 is at most 10, okay? Well, let's see. Things to remember. That's less than. That's greater than. That's less than or equal to. And that's greater than. Or equal to. Okay? So, the product of a number and 4, well, product is multiply. Okay? So, 4 times n is at most negative 10. At most. At most means it cannot be a product, the product of a number and 4 is at most negative 10. It cannot be more than negative 10. So it has to be less than or equal to negative 10. That's how you would sound that out, okay? You get 4n is less than or equal to negative 10. Divide each side by 4, and you get n is less than or equal to a negative 2.5. No. Okay, so some things to remember here. When dividing by or multiplying by a negative, we must switch the sign. Okay? Check this out. Which number is bigger? Right? Now, multiply both sides by negative 1. What numbers do you result with? You get a negative 2 and you get a negative 5. Now, which number is bigger? Well, the negative 2 is warmer than negative 5. Look what happened. We had to switch the sign, okay? Let's try something else. What about a 10 and a 2? Which one's bigger? The 10's bigger. Now let's divide each side by negative 2. That leaves us with a negative 5 and a negative 1. Which number is bigger? The negative 1's bigger. So that is why we switch the signs. Okay? So it's important that you understand the question, why? So, things to remember. When multiplying or dividing by a negative, we must switch the sign. So we want to solve this and graph this. We treat this thing like it's an equal sign, except for this rule. When we come across this rule, then we got to switch the sign the way the sign's facing. So we're going to distribute. You get 2x minus 3x plus 3. Remember, a negative 3 times a negative 1 is a positive 3. Is less, sorry, I shouldn't do it that way, is less than x plus 5. Okay, now just keep showing your steps. So let's combine like terms, and you get a negative 1x plus 3 is less than x plus 5. That's a 1x. Let's subtract 3 from both sides. You get a negative 1x is less than 1x plus 2. Subtract 1x from both sides. You get a negative 2x is less than a positive 2. Here's where the rule is going to come into play. Divide both sides by negative 2, and you get x. Got to switch the sign there because we divided each side by a negative. X must be greater than negative 1. 2 divided by negative 2 is a negative 1. Okay, so x has to be greater than negative 1. Is 0 greater than negative 1? Yes. So is 1. So is 2. So is a half. Well, there's lots of things that are greater than negative 1. In fact, how many numbers are greater than negative 1? Infinite. However, is negative 1 greater than negative 1? It is not. So that's why we put this open circle there. Because the point negative 1 does not satisfy this solution, this inequality. Okay, so some other things to remember would be, let's see, greater than, or less than, or greater than, open. Less than or equal to, or greater than or equal to, is a closed dot. A closed dot. Okay, moving on. Okay, so now we have ands. Okay, we have ands. And we have ors. So we're going to get to things to remember after we try these. If I divide each side here by 4, I get r is greater than negative 3. And, let's see, let's solve this one. They didn't really give us much room. 7r minus 1 is less than 6. Add 1. 7r is less than 7. Divide each side by 7. You get r is less than 1. So r is bigger than negative 3, and r is less than 1. Well, here's a spot, open dot on 1, an open dot on negative 3. I need all the numbers that are bigger than negative 3 and also less than 1. Would 5 work? Well, 5 is bigger than negative 3, but it's not less than 1, so no. Would negative 5 work? Well, negative 5 is less than 1, but it's not bigger than negative 3. So that's why we shade all the space on the number line in between the two open dots. How many numbers are there that satisfy this compound inequality? Infinite. There are infinitely many answers to this, which is why we have to graph the answer, because we cannot write all the answers down. Okay? You could also write that eventually. You'll see it written like this. This is maybe like a computer language, but yeah. Okay, so these are going to be a little harder to solve here. Divide each side by negative 2. You got x. I divided by a negative, so I got to switch my sign. X is greater than 3, or, all right, let's see, 2x plus 4 is less than a negative 10. Subtract 4. 2x is less than a negative 14. Divide each side by 2. X is less than a negative 7. So we have x is bigger than 3, or x is less than negative 7. So, put an open dot on my 3, put an open dot on my negative 7. The ors are easier to satisfy. I'm thinking of a number. How about 5? Is 5 bigger than negative 3 or less than negative 7? Yes, it is. So I plot it. In fact, all of these numbers will work. All of those numbers are bigger than negative 3. Sorry, bigger than positive 3. And these solutions will all satisfy our requirements. So for the compound inequality with an OR, there tends to be greater answer size. Think about it like this. If your mom told you to clean your room or take a nap, you would be thrilled. But if your mom told you to clean your room and take a nap, you would have some chores to do. So it's always easier to satisfy ORs than it is to satisfy ANDs. So when we have ANDs, the answers can look like this. They can look 3 ways. Okay? They could look like a segment. Here, let me change my font. They could look like a segment. They could look like a ray going in this direction. They could look like a ray going in that direction. Or you could have an empty set. There could be no solution to the problem. Okay? So these are our ANDs. When we have ORs, let's see. We could have all solutions work. We could have a ray going in one direction. We could have a ray going in the other direction. And finally, we could have 2 rays with the ORs going in each direction. So those are what your answers can look like. All right, I hope this helps. Have a wonderful day. Boom!